Section 5.8, application of polynomial equations, and in this example we're going to look at consecutive even integers. They're asking us to find three consecutive even integers such that the square of the first plus the square of the third is 208. So let's start out setting up what our three consecutive integers are. We'll let x equal our first integer. And if you had just an example of this, if I said my first even integer was 8, for example, how would you get to the next consecutive even integer? Well, you would have to add 2 to that. Well, I don't know that the answer is 8. So generically, to represent my next even integer, I have to add 2 just like I would with these as an example. I could have started with 22. How would I get to my next consecutive even integer, which is 24? I would be adding 2. We know that even integers differ by 2. So this would be our second even integer. And how would we get to the next integer? We would add a 2 to the preceding one. So if I add 2 plus 2, I would end up with an x plus 4 to get me to my third consecutive integer. As a side note, these variables also represent consecutive odd integers as well. If we started instead with 7, 9, 11 and wanted to generate that, our first value would have been x. How would we get to 9? We would add 2 to 7 to get to 9. How would we get to 11? We would add 4 to our 7 to get to 11. But we're looking for even consecutive, and now the relationship, we'll look at the problem. It says the square of the first, so we'll take our first term and square it, plus the square of the third. So we'll take our third term and square it, and it says this is a value of 208. To simplify, we are going to do a multiplication here. The binomial squared actually means x plus 4 times x plus 4. You can use the FOIL method to multiply this out, or if you know the shortcut of squaring the first term, squaring the second, multiplying the two together and doubling it, ultimately we'll get the same result. Using the FOIL method though, as I've written out here, first terms would give us an x squared. Outside would be a 4x. Multiplying inside terms together would be another 4x. 4x and 4x is 8x. Last terms multiplied together is a 16. And this is equal to 208. We have the makings of a quadratic equation. To solve this equation, we need it in standard form. That means the 208 needs to come to the left. And we have some combining of like terms. X squared plus another x squared make 2x squareds plus the 8x, and subtracting a 208 from each side ends up leaving us with a 192 negative is equal to a 0. Factoring then as our approach to solving this quadratic equation would be to consider greatest common factor, which there is one other than 1, it's 2. Dividing or factoring each term by 2 leaves a 4x, or x squared plus 4x minus 96 when we divide by 2 is equal to 0. Factoring the trinomial that we have here with a leading coefficient of 1, we're looking for factors of negative 96, one positive, one negative, that add up to be 4. And if you do a little checking, you should find a plus 12 and a minus 8 are the pair that work. We now can apply the zero product property, which means we're going to set these two factors equal to 0. Either the x plus 12 equals 0 to make this a true expression, or this factor, x minus 8, is equal to 0. The 2, being an integer, will never cause the equation to equal 0, so we can discard 2 as a possible solution. On its own, it doesn't equal 0. It's 2. So we will subtract 12 from each side. giving us an x is equal to a negative 12, and if you replace x with negative 12 plus 12 is our 0. Negative 12 minus 8 is a negative 20. 0 times negative 20 is a 0 times the 2 would be a 0. Here we'll add an 8 to both sides, and x is equal to 8. It also, when x is an 8, 8 plus 12 would be 20, but 8 minus 8 is a 0, times regardless of whatever else is here is going to give us a 0. So let's go back and see if we can answer the question. We have two possible solutions. It asks us to find 3 consecutive even integers. It doesn't state that they have to be positive or negative, so in this example, we actually are going to find that we have 2 sets of answers for this. If x is negative 12, and we add 2 to it for the next consecutive even, we'd be at negative 10. And if we add 4 to our negative 12, we are at negative 8. So one set of consecutive even integers would be negative 12, negative 10, negative 8, but we could also let x equal 8. So if we let x equal 8, and I'll write it over here to the side, x equals 8, x plus 2 would be 10, and 8 plus 4 is 12. The other set would be 8, 10, and 12, which it is the same numbers, only one, of course, one set is negative consecutive even, and the other is positive consecutive even. And just to verify this, they're telling us that the square of the first plus the square of the third is equal to 208. If you square negative 12, it turns into a positive 144, plus the negative 8 squared would be a positive 64, which when you add those together is equal to 208. And likewise, if we try the other 3 consecutive even integers that are all positive, the square of the first would be 8 squared. The square of the third would be 12 squared. We will end up with the 64 and the 144, which do add up to be 209.